Good morning, everyone. We are going to present on the topic data modulation, analog to digital converter. Our team members of our group name is Mentor Graphics. Our two team members are Ashvi Bandari, Shankar, Varun, myself, and Rohit. And our faculty in charge, Dr. N.B. Balamurugan sir. Now Rohit will continue with
Introduction.
introduction.
Natural signals are mostly in an analog nature. For the processing and the storage of signal, we need to convert the analog into digital form. One of the major drawback in the conversion is the need of an electronic device. So we are using the op-amp as a major tool for the conversion of the analog to digital signals. In this, one of the particular example of the analog to digital converter is a delta modulation. Delta modulation is the analog to digital converter. It is used to transmission of voice information where the quality is not of the primary importance. Delta modulation is the simplest form of differential pulse code in which the analog input analog signal which is compared with the average value of the analog input. When the average value in the input signal reaches the average value, which is considered as a logic one. When it reaches the below of the average value, it's considered as a logic zero. By using the digital principle, we are going to convert the analog into digital signals. In the delta modulation, the transmitted data are reduced to a byte data stream. Next slide. Features of the delta modulation techniques. The analog signal is approximated with a series of segments. The graph will show the series of how the series of segment is taken. Each segment of the approximated signal is compared to the preceding bit and the successive bit determined by the comparison. The graph it will be explained. You will understand it very easily. One of the change, only the change of information is sent. That is only an increase or the decrease signal is sent, which is used to analyze the analog signal and which is used to convert the digital signal. Then the digital signal is quantized and we get the digital output. Next slide. Yes, this is the example of the delta modulation in which the analog signal which is taken the red pulse indicates the average value of the analog input. The pulse we can see the pulse edges. When the input analog signal reaches the above value of the average, this will be compared as a logic one. In the below diagram we can see as the delta PWM signal. Similarly, by proceeding this diagram is for only one time period. We can do this for every time period and then we can get a digital signals. This is the example of the delta modulation, which is one of the easiest conversion of analog into digital signal. In where they can convert the digital into analog by the other methods such as auto converter and many other techniques are. Next slide. The principle. The modulation is made by the quantizer, which converts the difference between the input signal and the average of the previous steps. The graph we have saw on this. It is the simplest form. The quantizer can be realized with the comparator. Comparator is another one of the op-amp application circuits. The output can be compared with the average value. It is also known as a bit quantizer, as it quantizes only a bit at a time. Next slide. This is the block diagram for the delta modulation. This is just a use of a split triggerer and a low pass and an integrator also used in this modulator. The next slide will be explained by Varun Kumar.
Thank you, Rohit. The output signal power. In delta modulation, there is a restriction on the amplitude of the input signal because if the transmitted signal has a large derivative abrupt changes, then the modulated signal cannot follow the input signal and the slope overload occurs. Example, if the input signal m of t is equal to a cos omega t, then the modulated derivative input of the signal which is transmitted by the modulator which is represented by mod of m of t max equal to omega a. Whereas the condition to avoid the slope overload, mod of m of t max is equal to omega can which is less than sigma fs, where the fs is the sampling frequency. So the maximum amplitude of the input signal can be represented as a max equal to sigma fs by omega, where the where the fs is sampling frequency, omega is the frequency of the input signal, and the sigma is the step size in quantization. So a max is the maximum amplitude that a modulator can transmit without causing the slope overload, and the power of the transmitted signal depends on the maximum amplitude. Adaptive delta modulation. Adaptive delta modulation was first published by Dr. John the Abbott in the doctoral thesis at NJ Institute of Technology in 1968. ADM was the later selected as the standard for all NASA communications between the mission control and the spacecraft. Adaptive delta modulation, or the continuously variable slope delta modulation, is a modification of the modulator in which the step size is not fixed. Rather, when the several consecutive bits have the same direction value, the encoder and the decoder assume that slope overload is occurring and the step size becomes progressively larger. Otherwise, the step size becomes gradually smaller over time. The ADM reduces the slope error at the expense of increasing quantization error. The error can be reduced by using low pass filter. The ADM provides a robust performance in the presence of bit errors, meaning error detection and the correction not typically used in the ADM radio design. It is this very useful technique that allows for adaptive delta modulation. Applications of this modulator. The contemporary application of the,
Arun?
yeah, yeah, whether it's audible. Hello, Rohit. The contemporary application of the delta modulation includes, but is not limited to, the rotating legacy synthesizer waveforms with the increasing availability of SGCPA and the game-related ACSICs. The sample rates are easily controlled so to avoid the slope overload and the granularity issues. For example, C64DTV used as a MHS sample rate, providing ample dynamic range to recreate the SID output to acceptable levels. The ADC also required to process, store, or transport virtually any analog signal in the digital form. A TV tuner cards, for example, use fast video analog to digital converters, slow on chip 8, 10, 12, or 16-bit analog to digital converters are common used in microcontrollers. The digital storage oscilloscopes need very fast analog to digital converters, also crucial for software defined radio in the new applications. Digital mixing systems, which are commonly use analog to digital converters in digitalizing pixels. Some radar systems commonly used for analog to digital converters to convert the signal strength to digital values for subsequent signal processing. The number of binary bits resulting digitized, the numeric value reflects the resolution. The number of the unique discrete levels of this quantization is also known as signal processing. Thank you. On behalf of the team, we thank you for presenting us